Okay, hi. This video we're going to continue our new subtopic under determining standard expressions from a truth table. So if let's say you are given truth table, how are you going to contribute and make it out to have a Boolean variables of Boolean expressions. So from here, first you need to replace each binary number with its corresponding variable. So this is the important thing on this one. Although we know basically on SOP and POS, but sometimes it's also quite hard for us when we want to come out from the Boolean expression to the truth table and truth table to Boolean expression, because it's basically having two SOP and POS. So we need to exchange our brain to figure out this is for what and this is for what, similar to POS. So let's go. If let's say over here this is under SOP, first example, let's say you were given let's say you were given 1010. It's also mean it is a B bar, C, D bar. And you can see this is the output for 1 under SOP. For POS, the output will be 0. So it is just a repeating process. So next example is under POS. You were given 1001. So how are you going to convert it into your Boolean expression, which is A bar plus B plus C plus D bar. So you look into this one. And you're going to get 0 as your output. So let's check another. So if let's say you were given example of determining standard expression from a truth table. So this question you were given the truth table. You need to come out with the Boolean expression. So how we're going to do is, first step, you will look into this part. Let's say there is two truth table over here. Is it similar? Yes, 1010, 100. Okay, in one truth table, you can get SOP and POS. You can get SOP and POS Boolean expression. So for SOP, you will look into the output of 1, and the POS is going to look into the output of 0. So over here, in this truth table, you look first for SOP. Let's say this one, this is the output 1, this is the output 1, and then this is the output 1. So you're going to get 3 for SOP. 3 expression. This one is for your SOP, which is A bar. You can see over here, A represent as 0, B represent as 0, C represent as 1. For the input means that A bar, B bar, C. So let's conclude that you're going to have like this. This is the output for SOP. So A bar, B bar, C plus A, B bar, C bar plus A, B, C. So this is your SOP. So another 5, because you have 3 variable, another 5 will be your POS. So your POS will be the output of 0. So you look into the output of 0, so it will be over here. This is the 1, 2, 3, 4, 5. So you conclude it to be this for SOP and this for POS. Easy peasy, right? Over here you were given the exercise for B.11. You can try it, and there is also already there is also given the input and output. So what you need to do is you're going to find the SOP and then the POS. It's very easy. Remember, SOP, you look into the output for 1, and then you convert it into SOP, and the output for POS, you look into the 0. So both is 4. Or it gives you the example here. Let me show you the term. First term for the SOP, second term for the SOP, third term, and fourth. So now you conclude that your SOP is like this. Okay, next is on your POS. POS, you look into 0. So you get first term, second term, third term, and fourth. So lastly, you conclude that this is your POS. Now, before this, you learn on truth table. Now, there is another table that you can use also on to represent your Boolean algebra, Boolean expression, and to make it simplify. So it's easy for you to simplify it using the KMAP. KMAP is a similar truth table. It's similar basically, but it represents all the possible value of input and output. I think it's quite similar, nothing much, only that how you represent it in the way you draw the map, or sorry, the table. So this shown in an array of cells. So KMAP can be used for express 2, 3, 4, or 5 variables. The number of cells in KMAP is equal to total possible numbers input variable combination as a truth table. So here is the example of your KMAP. So if let's say you have 3 variables, you use the equation to the power of n, which is 3, you get 8 possibility or 8 cell. 8 possibility is 8 output, right? So it will represent it on cell for your KMAPs. So you have 1, 2, 3, 4, 5, 6, 7, 8. So what is basically this first cell here? So you look into this and this. So here is your A, B input, and this is your C input. So for your first cell, it is A, B, C is 0, 0, 0. For your second cell, you see that A, B is similar, which is 0, 0, but your C is different, it is 1. let's go to here. The third cell here, you look into AB input, which is 0, 1, and move up, you look into your C input, it is. So the fourth is like this, you look into 0, 1, and then move up, your C is 1. And until the rest, you will get 1, 1, 1 for this. Oh, sorry, over here. You will get 1, 1, 1 for AB, and here is 1. And you can see that it is like a switch, but basically you can also draw it by your own. But this is how the standard for the KMAP. You look like over here that there is, let me erase first, we move to here. So physically cells share the walls of adjacent. So cells refer by what variable are adjacent, so which is the side. And you can see over here that normally you will use 0, 1 first, and then it is 1, 1, right? So in this KMAP, we're going to draw 1, 1 first, and then 1, 0. And for the C is 0, 1, similar, only that if you have 4 variable, you will draw it like this too. Which is you will only vary on this one. Differ by only one variables are adjacent. And then I erase. So you look inside, this is the possibility, the value of what is represent for your input A, B, and C. And this one for A, B, C, and D for 4 variable. Cell 0, 1, 0 is adjacent to 0, 0, 0. 0, 1, 1, and 1, 1, 0. You can see over here 0, 1, 0. So it is adjacent for this, this, and this. So in, let's say you have like this, you pick this one, so the adjacent is the B side of the cell. Later on you will look into what is the purpose. So in KMAP, for 4 variable or more, the topmost and the bottommost cell or column, which is a row, are adjacent. This is for your useful if you want to make your Boolean expression simplify. So you want to simplify your Boolean expression, you're going to do this step. So over here, if let's say you look into this one and this one, they are adjacent to each other, similar to this one, and this, here and here. So you're going to have only 2 cell, 4 cell, and 8 cell. Let us see what is the purpose for 2 cell adjacent, 4 cells, and 8 cells. Okay, mapping standard for SOP expression. KMAP is used to simplify Boolean expression to their minimum form. This is the one that I mentioned. What is the purpose of all these adjacent? But it is simple. That's why I don't want to touch it much in this part, because if you basically will give an example from here, you will straightly understand. So a minimum SOP expression has the fewer possible term, for each term having fewest possible variables. So for the step to map an SOP expression to your map, you will use the KMAP. Step 1. Determine the binary value for each product term. And then for second step, place a 1 in cell that have the same value as the product term. So next slide. This is the example. If you look over here, you know that this is SOP. SOP Boolean expression. So from here, you're going to draw the map. You can see this is a standard SOP. So how are you going to simplify this standard SOP to make this simple Boolean expression? You need the KMAP. So from here, you're going to look into this one is, I delete first, 0, 0, 0, 0, 0, 1, 1, 1, 0, 1, 0, 0. This 4 term is having output 1. So you will draw 1 here, which is 0, 0, 0. And then 0, 0, 1, 0, 0, 1. And then 1, 1, 0, 1, 1, 0 over here, and then 1, 0, 0, 1, 0, 0. So you will be like this, and you're going to draw 0 to the rest. Is it okay? For the first step, we're going to get like this. Oh, it's not giving you the example, but this is how you're going to map to your KMAPs. After this, you're going to simplify it by using like this and like this. You're going to get the simplify. But later on, you will check what I'm doing over here. So you will get 2 terms only for the simplification. So let's see the example. Next example, this one is just for you to mapping into your KMAP. So this is the example. You can try it. This is not the point that I want to show you, because this one is very simple. You can just draw it, and I already give you the example also. And this one is on the POS, POS. Similar also, you can have your truth table, but the output will be 0. So the rest you will fill it with 1. You can try all the exercise, and it should be the example is in here. Okay, it's okay. I just move forward. So it is mapping non-standard SOP expression. To use KMAP, expression must be the standard form. So you need, let's say you were given like this Boolean expression, you need to convert it into the standard. So map the following KMAPs. Let's say you were given this one. So how you going to convert into your KMAPs? You need to do the standard form first. This one I already mentioned. I don't want to repeat because we already learned. Please take a look into all your 12 Boolean rules. So you will get the 3 variables for each term. And let me delete. And if let's say you already know how to make it standard, there is also another step. You can directly change it to A, B, C for all the term with the possibilities. Okay, I give you the first example. We look into A first. A bar. For A bar, you are missing B and C, isn't it? B and C, you have the possibility of 0, 0, and then 0, 1, and then 1, 0, and then 1, 1, isn't it? Because sometimes you will get BC plus B bar C plus B C bar plus B, is it correct? C bar, B C, B bar C, and then this one is bar. What I am doing over here, let me clear it first. Okay, you have A bar. So you are missing the B and C. So if you are using the standard form, you need to have B and C variable in this term. But you can also just make it like this one. But you can also have the possibility B and C, the possibility is 0, 0, 0, 1, 1, 0, 1, 1. Or B, C, bar, bar, B, bar, C, B, C, bar, B, C. So this is possibility, and then all of this will multiple to A. A bar. So the long way you will get A bar, B bar, C bar for the first, and then plus A bar, B bar C, plus etc. So this is how you're going to convert it long way. So the possibility is A bar. A bar, you know it is 0. So for B and C, you're going to have 4 possibilities, which is 0, 0, 0, 1, 1, 0, 1, 1. So A bar need to use the same because it is already fixed over here. So you plus, because over here there is a possibility. And A, B bar, you will do the same. For first example, I show you like this. So that's why you will get this, because this is the possibility for B and C. If I not drawing here, you don't understand what is this red number purpose, isn't it? So next, which is on your A, B bar. A, B bar, you missing the C. C, isn't it? You missing the C. So C will be having the 2 possibility, which is you normally use like, sorry, I don't want to show this one. Like this. You're going to have like this, right? So A, B bar, where is my eraser? Why I cannot pick the eraser? Okay, so that's why you will have 1, 0 fixed, okay? And C only have 1, which is to the power of 1. You get 2, which is possibility is 1 and 0 only. So that's why you will get this as this one is C. And you plus A, B, C bar. Is it okay? So all this possibility, this one is 1, 1, 0. All this possibility you will get 1 because this is S or P. So if 0, 0, 0, you will get 1. 0, 0, 1, you will get 1. 0, 1, 0, 0, 1, 0. Over here, you will get 1. And then 0, 1, 1. 0, 1, 1. So you will get 1. So over here, you already finished drawing it in KMAP. And this part, 1, 0, 0. 1, 0, 0. And then 1, 0, 1. 1, 0, 1. You will draw it as 1. Another one is 1, 1, 0. 1, 1, 0. So this is the one. So you will get like this. Is it okay? So it's just as simple, and over here it is a, suppose it's 0. Map the following SOP KMAPs to SOP expressions on a KMAP. So it's simple like this, and only this you have 4 possibility, but this part you need to make it to be the first one A, B. So there is another 2 possibility, which is 0, 0. This one is fixed, which is 0, 0. A, B. So over here this A, B, C, and then this one is D. So this part is fixed, which is 0, 0. So you have the possibility of A, 0 or 1. This one is D. You can also have the possibility of 0 and 1. But this one is 0 first, and then 0, 0. And then this is 1. You make it 0 first. Because the possibility of first, you use the 0, 1. And then after that, you can have another 0, 1, but over here it's 1, 1. It's not in sequence, but if you did understand, you will find out that this is very useful, because this one is A and B. You have 2 the power of 2. So 4 possibility. This you're going to draw 4 times. You can also do like this, 0, 0. So over here it is either 0 or 1. And then 1, 1. Either it is 0 or 1. Simple like that. So you can see over this how it's do. Similar, right? This is A and this is D. So same like here. You're going to you missed another C and D. So that's why this one is fixed, 1, 0. So 4 possibility, which one you will draw like this. And CD, this one is quite simple because it's just a normal in sequence. Sorry. It is normal in sequence, but the tricky part is when you having a separate place like this. So you can just do like this. This one is 1, 0, 1, 0. This is fixed as 0, 0, 0. So you can try to do the rest, and you will map your KMAP. I think it is over here. Followed by all of these. If your input is this one, so your output will be 1, or the KMAPs here. Let me try to show this example first. 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0. 1, 0 is here, and then it's 0, 0, 1, 0, 0, 1. I can draw it all, but it's okay. This is the answer. So the rest is 0. And how you're going to simplify the SOP expression? This is the one that I'm trying to find. So over here, there are 3 steps to obtain the minimum SOP. Similar also if you have a POS. But POS, please bear in mind, is different on it is the output 0. You grouping the first output first, and then determine the product term for each group, and then summing result. Maybe you didn't understand, but it's okay. You can straightly you can read it if you did understand on sentences, but I prefer myself on the example. If let's say you have over here, you can see the adjacent, there is 2, 4, or 8, right? So this is only the possibility that you can use. So this is having 2 cells, the side adjacents. So over here you have 1, 2 also. This one you can see that beside of it, there is nothing but that you can adjacent with your 1, value of 1 for SOP. I repeat again. So you will have this as like this only. So what is your output basically for this one? Oh, it shows you below. Sorry, I didn't realize. So this is the output that you draw it. So over here, let's be like me. Don't look into the answer first. So over here, first of all, maybe you look into, let me see this part you have on your right. Over here is this one, and your side is this one. So you can draw like this, because below also you have. And this one, you check right, left. So your adjacent only have 1 possibility. It's like this. How about this one? This one, you check also right, left. And you will like this. So that's why you will having the answer simply like this. Same also to the example number C. First of all, you start with 0, 0, 0, 0. So you look into your upper side, which is over here. It's linked to this other. There is nothing, so you cannot link to up. And then how about your left? There is nothing also here. And how about below? Yes, it is. And similar to your right. So if you have this below and right, so you will having the possibility of having this shape. And if you have this part, is okay. Now you look into here, up, no one, this one, oh, you have this part. This is linked to here. So you can draw long over there, but if you check over here, oh, there is something also. So that's why you will draw it long like this. And below, no adjacent. So you just draw like this. How about this one? You look into below. Yes, it's half. So let's check the possibility. Can I draw it to be square or rectangle? After that, you look into over here. So there is no possibility to have the rectangle there. And because of there is no upper and left side, so you just draw like this. And you can also have at your side, so just draw over here. If you draw this another one, when you minimize it, you can see that you have one circle and then there is another, so you cannot do it because you have the similar thing already. So you need to find out which part the adjacent that's still not yet covered. Similar also this one, you can try it by your own also. This one have the big square, which is 8. So now from this, the part that I want to show, from all these you circle, you do the rectangle, you draw the square, all of this you will use as a simplification. How you going to look into inside of the value. Let's check over here. Still under determine how to minimize the SOP from the KMAP. So the example on here, this is the example number A. So from here, when you draw it with your circle, you will get 0, 0, 0. It means that A bar, B bar, C bar, correct? So for this one, you draw it like this, the green color, you will have 0, 1. Let me draw it outside, so later on you will understand. 0, 1, 1 for your C. And then another one is 1, 1, 1. So please, you can see that the difference only at a part. So the fixed one is B and C. That's why you will get B, C if you simplify it. Because this one is possibility, means that you still have to like a standard form of SOP. So you will just take the part that's similar. Another example, I give you another example. For this purple color or pink color, this part is 1, 1, 0 and this part is 1, 1, 1. So what is the answer? This one, right? So this one is A, B. So let's take a look into another example. We pick the blue color first. Blue color, we have 0, 0 and then 0, 1, sorry, 0, 0, 0 and then 0, 1, 0. So which one is similar is this part and this part, isn't it? So you have A bar because this one is 0. This one is C bar. So you get this one. Okay, another example, we pick the smallest first, which is the black color. Black color, we will get 1, 1, 1 and 1, 0, 1. So the similar is here and here. So you will get A and C. And another one is over here. Before I show you the bigs, I want to make a conclusion first. For this KMAP, your simplify of your Boolean expression will be your SOP AB plus BC plus A bar B bar C bar. This is for this KMAP. How are you going to simplify from all your long, basically you will have your long standard SOP, right? But this one is your simplify, because you can see over here there is missing C, that is missing A, means that you already simplified it. That's why from your KMAPs you can get the simplify of your Boolean expression. So that is one. Now back to the big. Over here, for this one, you will have 0, 0, 0. And then this one is 0, 0, 1. This part is 1, 0, 0, and then 1, 0, 1. So you can see this one is not fixed, this one is not fixed, this is the part that fixed, and then it is 0, it means that B bar. So you get this. Your simplified Boolean expression from this KMAP is your SOP will be A, C, bar, bar. It's not continuous, it is A like this. Plus B bar plus A, C. Understanding easy, right? So next, it show also like this. Okay, this is the simplify from your KMAPs. So it's much better and much beautiful from if you compare to my draw. So if you pick over here, it is the fixed one, you will get this. So is it okay? So there is another example also, you can try it by your own. Group the first in each KMAP below, so you can try to draw it by your own. This one is similar, I think, but yeah, you can try it by your own. This is the answer. I think it's quite simple. And after that, you can have the minimum SOP. First, you're going to do this. What you're going to have, and this part, and etc. Give you the answer. If you have difficulty or you didn't understand, please just directly answer me. It's okay for me. I will try to help you to better understand. As long as you understand and you can answer others' question, not only from your module, you can try to get other exercise from other resources. If you don't understand, you can try to contact me and ask for my assistant. So there is a long example here. 1, 2, 3, 5, 6, 7, 8, 9. So change it to the standard SOP expression. You need to convert it, and of course you will get a long version, but over here you can see that only this one is missing. After that, you're going to this one is applied rules number 6, is the one that very easy for you to remember. And you're going to draw a KMAP from all of these. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 after you draw it. And how you're going to simplify it, you will draw and put it the adjacent part, which is going to minimize it, and you will get this answer from this long S or P expression. So it's easy for you to simplify and minimize, right? So there is also another example. You can just try to draw it and find the minimum. So this is the answer. Please try to do it by your own. So mapping directly KMAP from true table. You were given the true table and you need to directly convert it into KMAP, but it is just a simple, and I think it's much easier if rather than you were given the Boolean expression, because it's directly giving you the exact input, the exact point. So you just need to convert it into your KMAPs. So please try to do it. So nothing much, only that this part is very important, which is on don't care condition. Sometimes there are certain combinations of input variable that is not allowed. So the example is invalid combination in BCD code. So this one is the invalid. You look back your number system on the BCD code. This is the invalid value. So this state will never occur in application using BCD code. Hence, they can be treated as don't care term. So you need to take much precaution on this and look back what is the code that is invalid for BCD. And don't care term may be assist either 1 or 0. Its normally will be use the X, which is doesn't matter as it will never occur. So don't care term can be used for KMAP to process better result, which is used for part of group, large group. So you can use it for simplifications when it's group first, which is 1, value 1. The X can be treated as 1 to make the group larger. Later on you will see in the example. X can be treated as 0 if cannot be used for the advantage. So let's say like this. This part normally you will be not having the output for the BCD because that's because it is not it is invalid for BCD. That's why you will put it as don't care. Don't care is X. After that, you need to map it into your KMAPs. That's why over here you will have the output is 1, 1, 1. This is 1, 1, 1. And then the rest over here you need to point it as X. So if let's say you will have 1, 1 over here, you look into right, up, below and left. There is X, means that please turn it to 1 so that you can make it bigger circle. Similar also here, you make it 1 as long as you can make it bigger. So there is a possibility on that. Rather than, let's say you only have this part and this part, right, for this 1, 2, 3. But when you are using the first one, you will have this and this for your Boolean expression. But when you use the don't care, you will get this part, which you will turn it into 1, and you get this expression much more simple, and you will get this blue rectangle is represented as 1, much simple rather than this. So you will get A plus B, C, D for your Boolean expression after you use the don't care. See? Which one that you prefer? Either long way or this one is after with don't care. You will get much simple. So this is the part that invalid input for BCD. Invalid input, okay, not invalid output. So please try to do this exercise and apply the don't care. So this one, you will notice it is a sigma, so sigma is SOP. If let's say this is pi, so please make sure you know it is POS, then you need to put the output of 0 only. So KMAP POS minimization is similar, only that all this one you will put it 0. Just vice versa, the output will be 0. Like this is another example, you will put 0 for each term. And after that, you're going to simplify the POS expressions, group it for ones instead, for 0 instead of 1. See, it's grouping as 0. Just similar, that's why I don't want to touch it much, only that you need to understand between SOP and POS on term of, in the first beginning class, last video, I already repeat several times on what is the difference between POS and SOP. If you still have stuck in this, please check my video back and repeat it again. So try to do all the example and mapping all of these. So the next is on converting between POS and SOP using KMAP. It is a different way, which is from here you will have 1, 1, 1, which is normally for SOP. This one is SOP. And for 0, 0, 0, 0, it is for your POS. So first you're going to convert it all to your SOP, and next is, oh, it's not showing here. So you can use this 0, 0, 0 and you put POS using your KMAP. So get the sum term of POS and write the POS expression. So it is showing over here. So you can try, this is a self-test, that's why it's not giving you the answer. So you can try, just look into it. So I give you the first example, I just pick this one. It will be 0, will be A bar, B, zero, sorry. See, I also got confused sometimes, not sometimes, normally, because it's dealing with two different things. So this is 0, I will pick this one, A for 0, it will POS, 0, it will be A, and then B, this one is C, 0, D, 0, C, D. See, I forgot again. So please make sure that you didn't do like me. So this is for POS. Look into this one. The output, the input is 0, 1, 0, 0. And POS is not similar like this. So it in terms of, let me draw it first over here. A, B bar, C and D. This is for the input. So the representation will be A plus B bar plus C plus D. Then you multiple with, let's say over here I pick another one, 0, 0, 0, 1, A, B, C, D bar. So it will be A plus B plus C plus D bar. And then you multiple with this, 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 this. So you get your answer for your POS. Is it okay? So this is the example. After you get your POS, you can also draw the KMAP to minimize it. So you will use the adjacent step, and there is no, because of it give you the answer, so there is no not care purpose. So example number 4b.16. Transform for the following expression into KMAP, then generate the simplified expression. Okay, this one please make sure you try it by your own. Quite tricky, especially when it's gets into this part. So first you need to extend it and doing it using your rules. I just show you the example, the answer, but please try to do it by your own, okay? So get binary value, this one is also simple rather than the previous example, and this one is quite similar to 4b.16. Okay, we go another subtopic, simplify a combination logic circuit. This one quite similar, only that previously you looked into the truth table and the KMAP, but now you look into the logic circuit, because normally sometimes you were given the logic circuit, combination of logic, but there are too many logic gate that you are using, but you need to simplify it using a Boolean and also De Morgan theorem. So first step, you need to know what variables it's used, which is A, B, C, D, and then the output is X over here. Get the final output of expression. So you will be notice what is the output. So over here you will do it one by one. A bar, B bar, and then C bar. Over here it's C, and it started over here, this is D. So you can see that there is 3 for the at the end of this OR gate. That's why you have 1, 2, 3. So then after that it is AND gate. AND gate you will get A bar dot B bar dot C bar. After that you will go to the NOT gate. So NOT you will put all NOT after that like this. So this will be A dot B dot C bar 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 another bar. So over here you will get A, B B, C, bar, 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 another bar. And this one, the output over here, it will be A dot B dot C bar, 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 dot C, isn't it? So you will add all of these, you will get X. That's why you will having this answer. Similar, right? So you need to draw one by one. But this one is not the simplified version. That's why you need to simplify it. How? Use the De Morgan theorem and also the Boolean algebra rules. After each step by step, I don't want to show it basically on each rules and etc. because this one you already looked into. So please try to do many exercise on this because you need to get familiar with all the rules 1 until 12. That's why I mentioned for you last time, it's very important. And after simplify, you will get just like this. See, from all the long term, you will get just this one as the result from this. So you can try also, this one is example using your KMAP. How you're going to simplify it. I'm afraid that my battery is low. So from here, simplify the combination logic circuit using KMAP. First, you're going to do the standard SOP. After that, you will draw the KMAP. From the KMAP, this one you're not going to use your Morgan theorem and also Boolean algebra. It's quite hard, right? So there is another chance for you to make it easier just using your KMAP. So using the KMAP, you just draw the output and you will be having the simplified versions. So from all these, you will convert it into the equation. So please try to do it. And there is another also tutorial for you to try. So only that for this video. I hope that you can try this tutorial also. And maybe I will also ask you to submit as the assignment. So thank you for your watching and have a good day. Meet you again in next class.